Thank you. Okay, so we are beginning our regular discussion, but it's very good that you ask me questions. Okay, uh, it's very good. The introduction of LTE.
Sir,
Yep.
so can you just give a small short summary of the scrambling and uplink portion, sir? Just thanks. Small
Okay. You want me to go
the
back to
uplink.
CDMA and scrambling for uplink. Okay. Okay, I
Yes, sir,
will.
just that portion, sir.
Okay, let's go this way. In the last 10 minutes, since I have already opened this part, maybe in the last 10 minutes, we'll go back to CDMA. Okay. Um, okay. Now, for every uh, cellular communication technology, you have certain defined structure of for your network. Okay. So you have different components like I mean these guys, the blue guys are the base stations, and the base stations are called E node B in the case of LT. I think I wrote down these terms before. If not, let me do it right now. Give me a second. Okay. So in the case of 2G, sorry, in the case of 2G, the base stations are called BTS, base transceiver system. I'm just writing down the short name. Sorry. BTS. Oh, there is some delay in the application. Gives me some delay. And you call under the region under one BTS cell and then sector. Okay. There is some delay. Okay. In the case of 3G, the base station is called. Oh, it is. I don't know why it is causing so much delay today.
Sir, I think you can load the pen drivers.
Mhm. Sorry.
Sometimes if you don't load the drivers, it causes
Okay.
delay.
No, there is really too much delay today. Anyway, base station. See, it's not working well. It sucks. Oh man. Oh, not B. And the sectors are called cells. See. The region under one node B is referred to actually, I mean, the term node B is again used to indicate the region under the node B itself. In the case of 4G, you call it evolve. So the term E comes from evolve and E node B. So again, there is no cell and sector. We just call cell. Every sector will be called cell. And then again, the E node B you use somehow to indicate the region under under the base station. Okay. And in short, I mean, this term is shown this way: E N B. Okay. Now, you behind this base station, you have the core network. Okay. In the case of 4G, there is no node between the base station and the core network. The base stations are directly connected to core network. So these are some core network components. I'll formally give you the names for these core network components. And there is straight connection. These interfaces or connections are called S1. Have S1 interface between the base station and the network components and core network component. Now, these parts are referred to as the radio network. So, I mean, all in instead of using that word, let me write down here in the chat box that there are two parts. Okay, in the I mean, in all cellular communication network, one is called radio access network or RAN. Okay. And the second part is core network or CN. The in the case of 4G, in the radio access network part, you have only base station. That's it. But in 2G or 3G, there are two levels. Behind the base station, you had another nodes, and that was called. Okay, let's see if our. Oh man. Behind the base station, in the case of 2G and 3G, there were another set of nodes, and these nodes are called, in the case of 2G, it was called BSC, base station controller. In the case of 3G, it was called RNC, radio network controller. But in the case of 4G, you don't have this component. Okay, so you the E node bits are directly connected to core network in the case of 4G. So it is like you have, sorry. It is like the base station. Okay. In the case of 2G, was just connected to another component in the network, and then you have the core network part. Okay. So this part was called, in this part is our radio access network, and this one was BSC. Oh, it's really nagging. Okay. So anyway, you have BSC or RNC. It is it has two different terms. I mean, it is called RNC if it is 3G. But in the case of 4G, this base station is directly connected to your core network. Okay, core network components. Uh, so at the base station level, you have no, you don't have two. I mean, within RAN, you don't have two levels. Okay, like above base station, you don't have another level here in radio access. In the case of 4G, and so and the second difference between 2G and 3G is that you have interconnections among the base stations in the neighborhood uh, that we showed here. See, there are X2 interfaces among the base stations in the neighborhood. If in the close vicinity, you have these connections. These connections are not present in 2G and 3G. The base stations are connected to upper level components only, so BSC and RNC. But there is no direct connection between the base stations in the case of 2G and 3G. Well, we are just mentioning the architecture here, the network configuration, which is called network architecture. The advantage for
Sir,
4G, yes,
yeah,
yeah. What is the question?
sir.
Yeah. Do you see the PowerPoint slide? Can you see the PowerPoint slide? Hello? Do you hear me?
Yes, sir.
Okay. So, do you see this presentation? The network configuration? You do, right? Do you see? Hey, guys.
Sir, it's still showing start loading.
Okay. How is it now?
So not visible, sir, still.
What is now you can see, right? Do you see now? You don't?
Sir, still loading, sir.
Sir, the screen is showing black. The screen is showing black. Nothing.
Oh,
Sir, I think you can disconnect and then connect again. Then I think this problem will not occur.
I have just closed my PowerPoint slide and opening it again.
Yes, sir. It is visible now. So it is slide.
And you can see now, right?
Yes, sir.
Okay, I just restarted. Okay, so we spoke of two different connections. The base stations have no intermediate components, okay, when they connect to the core network. And as I said, the intermediate components are included in the RAN part. So you have two sides, RAN and core network. If you meet someone from the cellular industries, well, when two people from there meet, the usually the one of the early questions are which side do you work on, RAN or core network? Okay. So there are engineers on both sides, and there are the number of electrical engineers are more on the RAN side, and the people with computer background are more on the CN side, core network side. Okay. Now you may have a question: what advantage do you get with the difference in 4G? Well, there are few say the handover. Okay, when you are handed over from one base station to another. In the case of 4G, there are advantages. You can process it faster because you have a connection between the base stations already. Please give me a couple of minutes. Let me switch my internet option. Okay. Okay, sorry. Yep. Do you see the slide? Do you
Yes,
see?
sir.
Yes, sir.
Okay. Okay.
Yes, sir.
Uh, well, secondly, you have, I mean, when you do handover, there are advantages because of the direct connection between the base stations. These things we'll explain in detail later what the advantages are. Uh, secondly, you have some advantage in terms of latency. Latency means how long you take to transfer your data. So since you don't have any intermediate component, you can communicate with the core network quicker. Okay, so these are the major advantages. And thirdly, for interference control, you can have some interference control and some load balancing, okay, among the cells. So you can have some communication in the neighborhood within the cells and decide, okay, without any involvement from the core network. So there are some coordination uh, to set radio network parameters. So there are some advantages, okay, because of this connection in the among the nearby base stations. Okay, but how we put them along with other components in the network? Well, we know that the 2G and 3G networks are still coexisting, at least in our country, and so they have some components together with 4G. Well, the term RAN, okay, is like, maybe I use the chat box, okay, because of the delay, and this slide should stop. Say, in the case of 2G, the RAN is called, hey, what's happening? In the case of 2G, the RAN is called GRAN in short, okay, GSM Edge RAN. In the case of 3G, the RAN is called UTRAN. And you don't have to remember the whole term. The abbreviations are enough for this course. And this UTRAM, UT comes from UMTS, Universal Terrestrial, okay. And that's also you have in the case of UMTS, Universal Mobile Terrestrial System. So if you have UTRAN, in the case of, so the RAN, the RAN part is called GRAN or UTRAN. And for 4G, it is called EUTRAN, evolved UTRAN. Now, for UTRAN or GRAN, we know that there are two components. For UTRAN, you have Node B and RNC. For GRAN, you have BTS and BSC. But for UTRAN, you have just one component, just E node B. That's it. You don't have an upper level. You don't have a secondary level within RAN. So you form UTRAN using only E node Bs. Okay. Now you see that we show here utran, okay, and that forms that's nothing but the base stations. Okay. You have your UIs connected to your base stations, which are shown as utran. Well, uh, the base stations, since don't have a second layer within RAN, an upper layer component, it is called a flat architecture. The base stations are said to have a flat architecture. Okay, because in 2G or 3G you had two-layer architecture within RAN, but here it's flat. You have just all components in the same level, the base stations. So it's a flat architecture for RAN or UTRAN. Okay. Well, now.
Sir, can you raise your voice a bit more? We
Oh,
can.
really? Okay. But let me quickly check if the settings are all right. Where the settings are? Actually, I forgot where the settings are. There is some. Okay. Anyway, if it works, if I raise the voice, it's. Let me just do that. But do you see? Do you see the presentation now? Do you?
Yes, sir.
Okay. Now the network will have two kinds of uh, dealing with the phone, and this is how in the case of 4G these two kinds are handled separately. It wasn't the case in 2G or 3G. I mean, this separate handling. Okay, it is. I mean, you have a separation is made between these two kinds of handling. In the case of 4G, earlier it wasn't. And these two kinds are like, you have on one side you transfer your data. You have some concrete data to transfer between two ends. At the same time, there will be a lot of control from between the network and the phone. Many control operations will go on. Even I mean, before you have some active data transfer, or along with your active data transfer. So a lot of control operations you need. So this control and data, which are called user data transfer, so are separated in the case of 4G. Okay. And in the core network, you have a component here, serving gateway, which is like a router to handle the user data. So the base station will send just the data over this interface, forward it to the router. The router will forward it to your internet backbone. But before that, there is another node to I mean, its functions I'll shortly mention. It assigns the IP addresses. Okay, so the key purpose of this node is handling IP address. Okay, otherwise you could actually avoid this component. Okay, the router can just forward the data to the internet backbone. Now the control operation. For control in the core network, this MME, the whole term is Mobility Management Entity. I mean, but I say that the whole terms you don't have to remember. Okay. So the MME term, MME is the component in the core network to take care of all control operations in the core network. So the base station has separate connection between these two entities. In the case of 2G or 3G, this kind of separation control and user data handling was not there in the core network part. Okay, now there is a database in the core network, and it is called HSS. See the term mobility management entity, and serving gateway, SGW, PDN gateway, PGW. These things I have already explained. Now HSS is a database which stores all the user data profiles. When you register with when you first buy your SIM, your information is stored. You have certain phone number, and along with that you have certain charging method. Okay, the way you will be charged for your services. Different people, like in Grameen you have Shohoj and Nischinto, many different types of charging policies. So when you first become a subscriber, you will be given one of the charging options, and you also have your names and addresses. All this information are stored in the database called HSS. Okay. So when you start a call, the MME fetches the information. Okay, you are initiating a call, so with your phone number you can be identified. Actually it's not the phone number, we'll shortly see. There's some inherent numbering, inherent identities. Okay, so you're identified, uh, and then MME checks what kind of whether you are still a valid user or not. HSS has your information. Like some people are blocked uh, because of some unexpected activities. Uh, the network may have blocked you, so it is checked. Okay, what that your status is checked, and also what your current your charging policy. Okay, all these things are checked, and thereafter the charging part is taken care of by a third uh, entity, PCRF, okay, which makes sure that for all of your activities, you are properly charged. Okay, because charging is very important. Keep it in mind. Charging is very important from the viewpoint of the operator. They need to make sure they get the money properly. Okay, that's most important for them. Okay, this is something you can feel when you really work for them, because until you work, you'll see you'll find that they have different seminars and all that, and they'll have high sounding lectures there, that for the society we have been contributing this way, we're doing this and that for the society. But uh, at the end of the day, what they are interested in, how much money they can make. Okay, so this HSS, why it is not moving? Okay, so this HSS is connected here with the MME, and the PCRF is connected to PDN gateway. Okay, so okay, now you have the coexistence of 2G and 3G network. So you have JRAN and UTRAN, and they also have some core network component. So their core network component is called SGSN. For circuit, they have also the support of CS information, circuit switching, and packet switching. Both of them are supported, but LT supports only packet switching, and so the whole overall system for LT is also called evolved packet system. Okay, the whole network architecture is called evolved packet system. But for 2G or 3G, you have separate entities in the core network to handle CS and PS. And for PS, the entity you have is called SGSN. Now, when you have a coexistence, you have some connections, okay, with the between the 4G network and 2G and 3G networks. Like there will be some connection between the SGSN and MME. Okay, so there can be communication and they make some decisions. Okay, there are some optional connections also which are not shown here. The overall figure with all optional connections I'll show in the next class that I showed in my book. Okay, all kinds of mandatory and optional connections. Then there are a lot of connections. The whole architecture becomes complex. So that complex architecture I'll show inshallah in the next class. Now we have discussed equipment identity register is something not shown here but listed here. It's something about your equipment identity. Like you probably know already, many people already know that your SIM has an identity and your phone also has a separate identity, IMEI. Okay, we will talk about it later. IMEI, a separate identity. So every phone comes with a unique IMEI. When you power up, the network also stores this IMEI information. Or if you have your phone stolen and you report it to the network operator, they may blacklist. Okay, like in HSSs, a particular SIM number, okay, or user information, or a particular user may be blacklisted, and he may be blocked. On the other hand, your user equipment may also be blacklisted. Okay, so EIR stores the information of the equipments, okay, using IMEIs. Okay, now protocol stack. It is something you may have already got an idea about in some other courses. The basic protocol stack configuration for networking operation. Okay, we have some networking here. Cellular communication is one kind of networking. You have communication among many different nodes who are somehow connected to each other. Then it's a formation of network. And for network, there are many different types of processes, and these types have some generic generic characteristics. So these processes, well, then to organize the processes better, you can put them in different layers and take care of them separately. Well, in practice, separate people in the industries work on different layers. Okay, you have different group of people to work on different layers, to develop different layers, or even to check different layer operations. because the types of processes are different. Okay, so the overall process you can split into different layers. Okay, sometimes depending on which one you do earlier and which one you do later. Okay, uh, the the common configuration of this kind of uh, layering, okay, is called OSI model. So it is called OSI. But so for networking, when people learn networking, in the beginning they have to learn OSI model, which includes 7 layers. In OSI model, there are 7 layers. The bottom layer is called physical layer. And the top layer in OSI model, it is called application layer. Like the software you use is actually application here. Okay. Say you're downloading some web page. You have some Mozilla or other client software for web browsing. So that is that Mozilla will send a request to the web server. The web server will also run some application. Okay, that's a server application. Mozilla is your client software, and the web server will run some server application or software. So your application may want to fetch a web page, so it will send a query, and this request, the application, your client will first create a message that please send me that particular web page. So this message will be forwarded through other layers. I mean, this is the top layer from the 7 layers. It will be packetized, and in some layers, some headers or other fields will be added. Okay, and that will be forwarded to the next lower layer, on and on. This way, it will get to the physical layer, the bottom layer, and then the bottom layer will do its processes, and then I'm talking about the transmitting side, and then send to the receiver. The physical layer of the receiving side will receive, and the physical layer cannot understand. Actually, the message can be understood by the top layer, with the application layer on the web server side. The software, web server software can understand. But the physical layer will do opposite processes and forward it to the higher level. Then next higher layer, okay, so they will remove headers, okay, and do some processes depending on the indications of the headers. Anyway, finally the message that send me that particular web page will get to the application layer. The application layer or the software will fetch the web page, and then again it will forward to the second lower layer. It will be packetized and forwarded. The physical layer will send it to the client side. Okay, and again your Mozilla will get that web page information and display. So that is basically your OSI model. The name, the layer names, you have session layer and different layer names you have. MAC layer is something you have above physical layer. Now similar layering you have here, but in different technologies the actual layers differ a little bit. Like in cellular communication, it will differ a little bit. Okay, so let us now discuss how it is in the cellular communication. Well, but usually for a particular technology, you define uh, the bottom layers, like layer 1, layer 2. You have some technologies defined there, And for other layers, you may keep the same as you have in OSI model already. Okay, so like we'll see that we spoke of uh, the user data that you forward through the uh, serving gateway. Okay, the router. So in this case, for this user data transfer, the 3GPP specifications only define layer 1 and layer 2. Okay, I mean they talk about upper layers, but they don't define upper layers. You have only okay, I mean some technology definitions under 3GPP for L1 and L2. Okay. And for upper layers, you just use whatever you already have for in OSI model, like IP, TCP. Okay. Now, for control side, 3 different layers are, for control side, you don't have really, I mean, layer operations all the way up to the 7th layer. Okay. Only some lower layer operations are sufficient here, because you don't run a software on the other side. You don't have a real communication of data. Okay, rather you're doing some control purposes only that requires some signaling. Okay, that you find that this type of you are doing something this way, but the network thinks that it should be done in some different way. So the network sends a signaling information, a signaling message that change your way, do it this way. So you don't need the whole OSI, all the layers in the OSI model. Okay, so up to layer 3, you do. Well, there are a few. I mean, up to layer 3 on this interface, but here you have layers above that. Okay, but you don't have all 7 layers. Okay, now when you show, I mean, these layers in the model, it is called protocol stack. It's called protocol stack. Now you see, you have the phone, okay, UE, and layer 1, which is the physical layer. And you have, it's about user plane, for user data. So which uses the, I mean, path between, I mean, and the core networks. In the network side, you have E node B, then serving gateway, then PDN gateway. Thereafter, it goes to the internet backbone. Okay. But of course, you have the phone EV, so that is the physical layer, and above that you have 3 sublayers within layer 2. These sublayers are called MAC, RLC, and PDCP. So these are 3 sublayers. So this whole thing forms layer 2. So layer 2 has 3 sublayers. And above that, it's not something 3GPP defines. How, I mean, their operation procedures are not defined by 3GPP, but it is already defined in in RFC. Okay, some other specifications. So IP, TCP. So there are, I mean, you have other layers. All layers are not shown, but the top layer will be application, some software. Okay, now we see that only layer 1, layer 2 are handled here. Okay, and PDN gateway takes care of IP, handles the IP addresses and all that. So you have IP connection. But the other layers, you don't have direct connection or peer-to-peer understanding here within this side. I mean, you refer to the other end. Like I say that your Mozilla web client will talk to the software at the web server. So the message you are sending, that send me that web page. This message other layers will not understand, not on your side or on the web server side. This message only the server software can understand. Okay, or you're sending some email. So I mean, you have some email, maybe you're using Outlook or something, some client. So another software you have on the other side, they will understand. So the application layer message will be understood by the application layer message on the side. So no other layers, so no components within that between you and the web server will be able to understand that message. Well, so it may now be clear that there is a communication at peer-to-peer level. Like if your Mozilla client is generating a message, a request for web page or something, that message can be only understood by the software, by the application at the web server. The web server will send in response a web page. That web page can be displayed, okay, properly only by your Mozilla client. Other layers which help you communicate will not understand. There can be, I mean, it's not only cellular communication which supports internet, you know. So some other communication system will have some other layers below your application. But however they work, at the end when the Mozilla client gets the web page information, it can display. So it doesn't care how the lower layers are taking care of its messages, its message query, its web page query, or web page information, what it sends or what it receives. It doesn't care how it is handled by the lower layers. If if things it if things work for it, okay, it just show the web pages. Okay. So similarly, other layers also work with the other, I mean, layer on the other side. Like physical layer of your phone will work with the physical layer of the base station and nothing else. Okay, they can communicate. Like what kind of coding you used. The other end, you have to indicate the code rate, that I have used this kind of code rate. You have to indicate when you send your data. So you communicate with the physical layer of base station. If the base station doesn't know the code rate, it cannot decode the modulation level you have used. You have to notify. If you don't tell him what level of modulation you have used when transmitting data, the eNodeB cannot recover the data. Okay. So there will be some communication between physical layers. It will indicate this modulation and coding level I have used. And however things have been done at the physical layer, okay, should be recognized here for an opposite operation, for opposite processes here. Similarly, the MAC layer, okay, will do some processes and then forward it to physical layer. And physical layer doesn't care what it has done. It just cares what it has received, and it has to do processes on what it has received. This eNodeB side, after after the operation physical layer, will forward it to MAC layer. Then this MAC layer may have included some indication, okay, before forwarding it to layer 1. Maybe the MAC layer has added some header, and the header includes some messages, okay. The header fields indicate something. This MAC layer will be able to read those MAC information, okay. You'll be able to read the MAC header and get the information you have inside. No other layer will be able to read the MAC header and understand what it says. So there is always peer-to-peer understanding or communication. Okay. Although you can argue that there is direct communication only direct data transfer only between physical layers. You launch the data, okay, and the physical layer on the other hand receive the data. Even the reception by the antennas are included in physical layer operations. So direct, I mean, communication, like in an office, you, I mean, between two offices, uh, there is some communication, maybe using a postman. You have sent a letter to the other office. So the guy at the other, I mean, maybe the security guy at the other office just receives, okay, and then forwards it to an upper layer officer. Then it is forwarded. I mean, people find that okay, no, it is actually destined for someone else at even higher level, and maybe it finally goes to the owner, proprietor of the office. So the proprietor will open the envelope and read it. The lower layer officers will not be, even if they open, look inside what you have inside the envelope, they cannot understand. Okay. So there is always communication, but you see the later, I mean the owner of one office or one industry, one company didn't take it to the owner of the other company. It is, I mean, the direct transfer of the later occurred only at the physical layer level, only at the lowest layer level. Okay, the postman. So, but virtually there is the communication at the same layers. So that is why these lines are drawn between the same layers, same layers. Okay. Now we are interested in this RAN operation. There are also, I mean, as you forward it to serving gateway, I mean, you again have some type of protocols working, but these things we want to look into. Okay, I mean, this side is wireless, this side is RAN, and this side is within core network, which we are less interested in. At the IP layer, as I said, that the PDN gateway manages IP. Okay, so there will be some communication about IP, but the actual packets are just forwarded. Okay, like serving gateway forwards the packets, it also forwards the packet to the internet backbone. Okay, questions? Questions, please. There should be quite a bit of questions. There, I mean, the CDMA principles I have explained. If you have really gone through it, and if you are also attending all these discussions that I've been doing now, I think you should have some questions in your mind. Okay, and if you have them, if not today, ask them, please. I mean, when you get some questions, write them down, preserve them for me, and the next day, please ask me. I'm not granting that I'll be able to answer all of your questions, but hopefully I will be. And if not, I'll just check on it and come back with the answer the next day. Okay. You shouldn't feel ashamed of raising your question, and I shouldn't feel ashamed of saying that I don't know. I need to check on it. Okay. Like the questions you raised today in the beginning, I wasn't very comfortable with that because it's not very I mean, not well related to what I look into. It's about the temperature of your phone. Okay, um, that's not that, you know, the temperature level. Even if you have some, I mean, computers, okay, which is not using cellular communication or any other electronic devices, okay, uh, you get things hot. For all electrical equipment, you get things hot, or sometimes too hot, sometimes moderately hot or warm or something. So you get the temperature level different for different types of activities, for different type of electrical equipment or electronics equipment. So these things are not really my own area. Okay, but of course the phone also supports cellular communication, and then there is some impact. Okay, I mean, the processes that you are doing for cellular communication will definitely have some impact on the temperature level. Okay, uh, but I never focused on these temperatures of the devices. Okay, it's almost the end of our normal class period, but if you have questions, please go ahead with them.
So I think many of us are still
Sleeping.
coping.
Are-
No, sir, still coping
Okay.
with this new topic. I think at weekend, many of us rewatch these videos to catch up with the things that we miss. There's something that's yeah, we may understand in the class, but when we rewatch the video, the idea gets clear and our the idea gets reshaped. Then many interesting question arises from
Yeah.
revision.
It will be
I
good
think-
if you really come up with questions and we make our classes interactive, then you will be able to learn better. Okay. So don't hesitate if you really have questions.
So I think,
Okay.
inshallah, you will face many questions in the
In
next class.
future. Okay, volley of questions. Okay, inshallah. I'll make self ready ready for that. Okay. Some shelter to face the bombardment of your questions. Okay. Then let us wrap up for today. Thank you for your time.
Assalamu alaikum, sir.
Walaikum assalam.